the aspect of current electricity. Current electricity. Here under current electricity, we'll be reviewing various questions which can pop up talking about your Jamb examination. Is it questions with regards to current, calculating the value of current in a circuit? Is it with regards to questions surrounding resistance in a circuit? Is it with regards to what? Calculating EMF or potential difference in a given circuit, not forgetting that we have internal resistance which can build up in a circuit. So all these and more are what we're going to be looking at. So let's get right into it. What are the key things that we need to put in mind anytime we are dealing with current electricity? The first is the fact that Ohm's law is always obeyed under current electricity. Ohm's law mathematically is represented as V is equal to what? IR. Ohm's law stipulates that the voltage is always a function of the product of what? Current and resistance. We should also not forget the fact that we have that power under this instance is equal to what? IV. Power is equal to IV. And we shouldn't forget the third statement indicating that what? Energy is the product of power and time. On these three key formulas, we build other what? Other mathematical expressions with regards to current electricity. So here's the catch. We have these parameters. You shouldn't forget that what? E here is standing in the place of energy. Energy. While we have EMF being equal to also E being equal to I into brackets big R plus small r. Not forgetting a fact about resistivity of the wire in which we are using, which stipulates that resistivity rho is equal to RA over L. RA over L. Now, number 6, we're going to be working with the fact that we have our connection in series and connection in parallel. Whenever we're making reference to connection in series, it's a subject matter that we have resistance in series, we're using R series to be equal to R1 plus R2 plus continuation of the number of resistors in the circuit. Similarly, here we have power. So for clear instances, P here is power, electrical power, don't forget, electrical power. P equals IV. Here, voltage or potential difference. Potential difference, V equals IR. So, working with this, number 7, we talk about resistance in parallel. Resistance in parallel is such that 1 over R parallel equals 1 over R1 plus 1 over R2 plus whatever variant of resistor we have, depending on the number of resistance in the circuit. So here is it. We'll be having more formulas added along the line of the questions we'll be seeing in our Jamb Pass question. Remember, the more you get yourself familiarized with your Jamb questions, the easier for you in delivering the excellence which you desire. So let's get right into it. The first question of the day with regards to what? This aspect. So, first question first. We have this. Number one, three cells, each EMF 1.5 volts and internal resistance of 1.0 ohms are connected in parallel. Across a load resistance of 2.67 ohms. Calculate the current in the load. Calculate the current in the load. So here is it. We have the questions before us. Three cells, each having EMF of 1.5 volts and internal resistance of 1.0 ohm, are actually connected in parallel with another load resistance of 2.67. So we are to determine what current would be available in such circuits. Have it at the back of your mind that any moment we are making reference to EMF, we say that EMF in parallel is such that E total or E parallel is equal to E1 equal to E2 and so on and so forth. The EMF in parallel is such that what the value is the same whenever you're having what connections in parallel. But whenever you're having EMF in series, it becomes additive. EMF in series is additive. E1 plus E2 plus E3. EMF is additive in series connection. It is actually what? It's the same in parallel connection. So having this in place, solution. We write out our parameters. We have three cells that have EMF of 1.5. So it means that what? EMF of 1 is actually 1.5 volts. EMF of the second cell is another 1.5 volts. EMF of the third cell is another 1.5 volts. We say that EMF in parallel is equal to all the what? The component EMF. So it's going to be equal to 1.5 volts. The EMF in parallel becomes the same. The total EMF in parallel is the same as each value of the constituent cell. We have the internal resistance. We have that what? The internal resistance will work with respect to what? The formula of resistance in parallel, such that we have R in each cell. Small letter R is used to denote internal resistance, 1.0 ohm. R1 has this value. R2 also has this value, 1.0 ohms. R3 also has the value 1.0 ohms. So we say 1 over R, small letter r, in parallel becomes 1 over R1 plus 1 over R2 plus 1 over R3. Putting in our value, the parallel 1 over R parallel becomes equal to 1 over 1 plus 1 over 1 plus 1 over 1. We have 1 over R parallel to be equal to 3 over 1. Don't mix it up, please. Note that the LCM here for 1, 1, and 1 is 1. 1 plus 1 plus 1 gives us 3. That's what we have here. So, such that what? We cross multiply. Such that we cross multiply, and we have that 3R parallel becomes equal to 1. Divide both sides by 3, and we have that R parallel equals 0.33 ohms. That is the connection of the internal resistance in parallel. We are given the external resistance, which is the load resistance, having a value of 2.67 ohms. Find the current. The general formula. EMF, number 4, stipulates that the product of the current and the combined resistance gives your EMF. So EMF, which we already have, we calculated the total in parallel, 1.5 will be equal to I value, which is what we are looking for, multiplied by 2.67 plus 0.33. And from here, 1.5 is equal to I multiplied by addition of everything here gives us 3. Addition of everything here gives us 3. And from here, we have that we divide both sides by 3. I becomes 0.5 amperes. I becomes 0.5 amperes. So, option C, based on the question, I becomes 0.5 amperes. What did we do? First, we take into account that EMF in parallel is not additive. You consider it that what? The EMF in each constituent cell is the same when you take the combined connection in parallel. While in series, we said that addition of each component of the cells give the total what? The total combination in series. So with that, we're able to calculate the value of what? The EMF in parallel. Having solved that, we went ahead to determine what the resistance is going to be in parallel. Note, why am I using small letter R here? Small letter R denotes internal resistance of a battery. Take for instance, you have your battery, you have the nylon wrapped around it. The EMF is 100%. You have the efficiency of such battery to be 100%. Why? You've not used it. When you take your measurement, you have the battery reading 1.5 volts, for example. The moment you tear off the wrap and you have it placed down, even without use, internal resistance build up, and over time, when you take the measurement of such a battery, you don't have 1.5 again. It gets reduced. Internal resistance is that resistance present within the cell itself. So that is represented by small letter R. We calculated the parallel connection of our internal resistance. 1 over 1, 1 over 1, 1 over 1. LCM is 1, while the additive sum up gives us 3 here. Cross multiply your work. Over time, I've seen students solving Jamb question, and when they arrive at this stage, they just leave it as 3. Trust me, Jamb would what? Stipulate answers. They will generate answers around you using the wrong values. So wrong options are also available. So take note of that. Having this in place, then we use number 4 formula to get the what? Value of the current. E is equal to current multiplied by the sum of external resistance plus internal resistance. And that's what we did to arrive at 0.5. So, observe closely. How many of the formulas on the board have we used? We're able to use number 4 formula. We're able to adopt number 7 formula and number 8 formula. So 3 formulas for 1 question. That speaks volume. When you are preparing for your Jamb, understand that a combination of 2 or more formulas would be needed sometimes to solve just 1 question. We move to the next. We move to the next question. So, here we go. And in case you're wondering what the diagram will look like, what is the diagram going to look like, or the circuit diagram for this kind of question, it would be in this form, whereby we have a parallel connection of the EMFs. Here, long and short. Here, long and short. Here, long and short. So this is what the connection of the battery, the cells look like. Here is 1.5 volts, comma 1.0 ohm. This is how we write the EMF and the internal resistance. 1.5 volts and 1.0 ohm. 1.5 volts, comma 1.0 ohms. So note when you see them put in the resistor beside the cell, then they are making reference to what? Internal resistance. The external resistance will be connected as well. Here we have our ammeter reading, then we have our resistor connection, where this will be 2.67 ohms. This is our big R. This is our E1 with respect to R1. This is E2 with respect to R2. This is E3 with respect to R3. So this is how the arrangement of such what? Such circuits is going to look like. So know how to what? Pick your values from the circuits. Know how to pick your values from the circuit. So for those of us joining on TikTok, you know that what? The speed and tempo of the class, live class, might not avail you towards write out the questions as fast as possible. You can always take a screenshot of what the questions are, the question sets are, so that you can review later on. And for easier flow, you can always join us on the platform. We have what? A section created whereby you can have these live classes released to you, the video recordings released to you, just for what? A token. Don't worry, all that will be made available on the platform, whether you're on Instagram, TikTok, or YouTube. So, next question quickly. So, 3 out of the 4 formulas. 3 out of the 4 formulas. Out of the 9 formulas on the board has been used. 3 out of the 9 has been used. Let's have a look at the next. This has something easy for us to work with. Here is it. We are told that, question 2, an equipment whose power rating is 1500 watts and resistance is 375 ohms would draw a current of question mark. Is it 0.10? Is it B 2.00? Is it C 4.00? Is it D 77.5? So which of the values do we have? So here we go. To solve this, we take into account the values given to us, and based on your what? SS1 to 3 programming. At this stage, you should know exactly what unit stands for what. What unit stands for what? In terms of the what? Alphabets of the unit. You should be able to You should be able to what? Determine what physical quantity we are considering based on the units. So when we have 1,500 watts, we are talking about power. 1,500. When we have our ohms, we know we are talking about resistance, alphabet big R, 375 ohms. And we're asked for current, alphabet I, question mark. But checking our formulas, you discover that we don't have any formula that combines power, resistance, and current together. So what do? We tend to what? Pick values that we can what? Imbibe into each other. We can combine such that if we have P as being equal to IV, we can easily say that what? V is equal to IR, meaning we are using number 2 and number 1. V is not given in the question. As such, we can what? Substitute the representation of V with IR. Power now becomes I in multiplied by what? IR, which is the value of V. From here, P becomes equal to I square R. P becomes I square R. Putting in the values that we have there, 1,500 equals I square multiplied by 375. I square multiplied by 375. We divide both sides by 375. 375. So we have 4 as our answer. I square becomes equal to 4. I square becomes equal to 4. I square becomes equal to 4. From here, we know I equals 2. Square root of 4 gives us 2 amperes. Option B. You can see that for every question posed tossed at us, we can easily have that solved out. We were able to use Formula 1 and Formula 2 in solving this question involving power. Involving what? Power. Let's look at the next one quickly. I'm sure this is quite straightforward. Picking Formula 1 and Formula 2 in solving our question. So let's proceed looking at something else with regards to this. So another question quickly. Here, under resistivity, we have a question under resistivity. So that should be Formula 5. Resistivity, Formula 5. So let's see. The question has this to say. A wire of length 15 meters made of a material of resistivity 1.8 times 10 raised to power minus 6. Unit is ohms per meter. Ohms meter. So resistivity is given as ohms meter, and we are having the resistance (0.27 ohms). 0.27 ohms. We are asked to determine the area. Determine the area of the wire. Determine the area of the wire. Quite a straightforward question. That's why questions under resistivity, any question under resistivity spells an easy task. It doesn't what? Look like something complex, except for the fact that you don't know the formulas beforehand. And that's why I'm presenting to you today that what? Look no further. We are not looking at too many formulas under what? Current electricity. Just some few formulas